All right, so before we start vectorization, I just want to see if this dictionary is giving the information that we asked for. Yeah, so we're going to create a variable x, and we're going to look in the car indices dictionary, and I want to know which index is associated with this character a. So let us do a print x and run this code. Here you go. So this is as expected. So now we're ready to start vectorization. All right. And we will do this with this block of code. This we explained during the brief as well. Yeah, there's basically two arrays. One array is called X, and this array contains 200,000 rows, which are the sentences, and then the columns will be 60, one for each character in that sentence. And then in the depth, we have 57 unique characters. So these two first one here will give you a matrix, and you will have this matrix for each of the 57 characters. For example, your first matrix would have these sentences 60 columns and the first unique character. And basically what you're gonna do is whenever you see that unique character, you're gonna put a 1 there. And when you don't, you're gonna put a 0. And that's why the data type here is Boolean. Yeah? So for the Y array, basically we have our 200,000 sentences, and then we have the predicted characters. Yeah? So there's 57 possibilities here. All right, so let us now print the shape of these arrays and see if we get what we wanted. So here we go, and that's exactly what we expect. All right, so now we're ready to train our model. Let's train our model and derive GRU parameters. All right. So here we go, and the block of code that we will use will be this one. So here we do our traditional library imports, and there's just the other ones we've seen, but there's two new ones here. One is called load model, and the other one is random. Yeah. So we're gonna see where to use them later. But basically, we build a sequential model as usual. We have our GRU here, and that has a length of 64 when it comes to the hidden state. We have dropout, recurrent dropout, and of course the data that we take in is a sentence of 60 characters. And then with 57 possibilities in terms of unique characters. All right, and then the model compile, we use RMS prop because we do a softmax activation. This is categorical cross entropy. Then we fit our model, batch size 64, 20 epochs, and then we're gonna save the model under Nietzsche model. All right, so let's now run this model. Here we go. So we started running, and this is the first epoch out of 20. All right, so here we have the outcome of the epochs. We've taken 20 epochs, but if you see here, we've not gone through this 20th epoch in full. That's not a real issue here, so I assume that the model has been trained now and that the model parameters have been set. So the next thing that we need to do is we need to reweight that probability distribution. So we have to sample from softmax. Yeah, so now you have a certain probability distribution, and the outcome of a prediction will be a vector of 57 elements. And each of these 57 elements has a probability to be chosen. Yeah. And remember, in order to do generative learning, or generative deep learning, what we need to do is we need to reweigh that softmax. Yeah? So, and the tool that we will use is, for example, the temperature. So let us paste a block of code that will help us to sample. So basically, you're gonna sample from your softmax, and the temperature that we've chosen is 1. Remember, low temperature, low randomness, high temperature, high randomness. Yeah. So the extreme of high randomness is that each character has the same probability of being chosen. And that's not what we want, because it will not generate a very good language model. On the other hand, we have very low randomness, and that means that we will predict mostly the same character. This will also not be ideal in terms of language model. So what we need to do is pick a temperature just between these two. Yeah. So what does this function do? Well, it takes the outcome of your softmax. So you put an input in, an output, a softmax is generated predicting the next character. Well, the first thing you're gonna do is convert this softmax into an array and make sure the type is float64. Remember, we're gonna have numbers between 0 and 1, and we're gonna have 57 of these numbers, and all of these will add up to 1 as well. Second line of code here is where the temperature comes at play. I took a temperature 1, so basically this term disappears. But we still gotta take the log of the softmax. And why do we take a log? Well, because a log avoids to deal with a large amount of very small numbers or small probabilities. Remember, we often multiply probabilities, and it's not very convenient if these are very low. So in the next step here, we actually take the exponent of the softmax. And the softmax in the meanwhile is this one here. So if we take the exponent, what it does is it creates more space between the values of the softmax. So it amplifies the given probability distribution. After doing that, basically what we will do is rescale the numbers and make sure they're all between 0 and 1. And also, if you sum them all up, they should be equal to 1. Once this is done, we're gonna sample, and we're gonna use a multinomial distribution to do the sampling. So basically, we do one experiment. Yeah. There is a softmax or 57 potential outcomes, and we just take one outcome. Which is the outcome you take? Well, you choose the outcome with the highest probability of success.